There may be plenty of situations in which you want to execute the same section of code multiple times in a row. A loop is a control structure that allows us to execute a statement or group of statements multiple times, depending on whether particular conditions are met. In essence, when the script comes to your loop, it analyzes the condition. If the condition is true, then it performs the conditional code and then reanalyzes the condition. It will keep doing this until the condition is false, at which point it ignores the code. Lua provides us with 3 different types of loops, which are all very similar but have slight variations on how they handle their conditional statements. A while loop repeats its code over and over again while your conditional statement is true. If the conditional statement never changes, this loop will continue indefinitely and will error out. A for loop will execute its code for a predetermined number of times, which you can define. And a repeat loop will repeat its code over and over again until a specific condition is met. Let's build some simple loops demonstrating each of these types, and then we'll apply them to our Q-SYS design. First, the while loop. Let's define variable x as 5, and we'll build a loop that will increment x by 1 until it reaches the value of 10. So, our conditional statement for while can be x is less than 10. Then, we add the very important reserved word of do, which starts the body of our conditional code. We're simply going to take x and redefine it as its current value plus 1. Then we'll print the new value x, so we have some record of this loop occurring, and we'll type end to finish our do statement. When x goes into this loop the first time, it will add 1 to it, turning x into 6, and then it will print 6, and then return to the conditional statement. Since x, now being 6, is still less than 10, it will go through the conditional code again to become 7, and then 8, then 9, then 10. Now when it reaches the conditional statement, it does not qualify as being less than 10 anymore, so the do code is not performed and the loop is over. We can validate this by running our script, and we can see that our debug window prints x at the end of each loop and then stops. Now, to our eye, it appears that this all happens instantaneously rather than sequentially, but rest assured, the computer is doing one loop after the other. Next, let's do a for loop. This is a determinate loop which will only run once for every iteration that we specify. I'll remove the while conditional statement and replace it with for I equals 1, 5. Here, I represents an iteration, or an instance of the loop. The first number here will be the number we start at, and the second number is the number we want to stop at. If we run it now, it'll appear to do the same thing as our previous loop. On the first iteration, it ran this loop and changed x to 6. On the second iteration, it did this loop and changed x to 7, etc. After the 5th iteration, x is 10, and the loop is finished. But the reason why it's finished is completely different than our previous example. In our while loop, it finished because x no longer met the conditional statement. But in this loop, it finishes because it has simply terminated its instructions on how many times to run. I also want to point out that I has nothing to do with x, nor does it have to start at 1. I could have this run from 22 to 26, and it would give us the same results. It runs a loop for 22, another for 23, 24, 25, and 26. This is simply a range, but the 22nd iteration does the exact same thing as the first iteration. Lastly, let's write a repeat loop. Once again, I'll keep my conditional code, but let's replace this first line with the command repeat. The biggest difference here is that the repeat loop doesn't start with the conditional statement, it ends with it. This means it performs its first loop no matter what, and then validates whether it should continue after that loop is complete. As far as our syntax goes, this means we don't need anything other than the word repeat to begin our loop. We can also replace end with our conditional statement of until. Now we define what that conditional statement is. In this case, x is equivalent to 10. It's a very similar concept to the while loop, but the while loop performs its analysis first and then does the work, while the repeat loop does the work first and then analyzes if it should continue. So let's combine this with some of the other tools we've learned so far to make a loop that's actually useful to us. We could use a loop, for instance, to simplify an otherwise repetitive script. Take a look at this scriptable controls component, in which we've added 5 toggle buttons named Flippy, and inside we're using the first Flippy's event handler to launch a function. This function contains an if-then statement. If Flippy's value is 1, then its .legend reads on, else its legend reads off. We can see that this works. Our button displays the appropriate label based on this script. But that only works for the first button. If I wanted to give every button this same behavior, I'd have to duplicate this script 4 more times, right? Well, not necessarily, because we could use a for loop. Instead, I can simply add a for conditional statement, for I equals 1, 5, do, and then it will do this script. All I need to do is replace the index of each control. Rather than reference that first control's number, I'm going to reference the ith control. In this case, it's going to use our iteration number as a variable to apply within our function. So on the first iteration, it writes this function for Flippy number 1. On the second iteration, it writes this function for Flippy number 2, etc. All I need to do is end my for loop at the bottom here, and my work is done. Every one of my controls now has the same behavior, and I did it with just 2 lines of code rather than dozens. If you start scaling this up to a lot more than 5 controls, you can see how much time and processing it could save you. Also, we see here an example of why our iterations in a for loop don't always have to start at 1. I could define this for loop to run from iterations 2 through 5 instead, which would only affect controls 2 through 5 if I wanted 1 to have some different type of behavior. All right, let's swap over to the block controller and build all these loops there. You'll find the loops under the flow control section. First, let's grab this repeat block. This should look familiar. It's currently set to a while conditional statement, or you could change its dropdown to an until conditional statement. Just like we did in Lua, we'll establish a variable and set it to 5, and then we'll perform our while loop with the condition that x is less than 10. So we'll need to grab a logic operator and change it to less than. And we'll go to our variables and grab our x, and then grab a value for the second half and set that to 10. For the mouth of our statement, or the do section, we'll go back to variables and set x to something else. We need to do some arithmetic here, so we'll go back to operators and grab this addition block. Once again, we can grab our x variable for the first slot and a value of 1 for our second slot. All that's left is to go to the system folder and grab a debug print block and have it print our new x. All right, if we look at these two side by side, they are the exact same thing. X equals 5, and while x is less than 10, we add 1 to x and print it. In fact, if we look at the Lua output of the block controller, we can see that it is generating the exact same Lua, word for word, as the while loop that we wrote ourselves. However, I want to point something out to you. Let's change this while loop to a repeat until loop. On the Lua side, you'll remember that this means we move the conditional statement to the very end. On the block side, we simply need to change the while to until. But let's also adjust our conditional statements so it will repeat until x is greater than 9, which will give us the same result as our previous script. And I'll do that on both sides. All right, so far so good. But look at the Lua code the block controller is generating. Rather than writing a true repeat until loop, it simply changes its while loop with a not modifier, while x is not greater than 9. Sure, it does the same thing for now, but there's one special case where this might be problematic. I mentioned earlier that the repeat loop performs its loop first and then checks its conditional statement to see if it should continue. So what if the conditional statement is already met before the loop begins? I'll change the until to be greater than 0 rather than greater than 9. When x starts at 5, it's already greater than 0. A Lua repeat loop will still, regardless, run through its loop once before checking its conditions. So we get a debug showing us that it went through one cycle before realizing the condition is met and it stops itself. But the block controller is still a while loop in disguise. So it checks the condition first, and since 5 is already greater than 0, it doesn't perform the loop at all. So these two functions may appear to be identical, but we get a slightly different result. This probably won't ever be a big deal for you, but I thought it was worth mentioning. All right, finally, let's build our for loop with the block controller. We'll replace the repeat block with this for each item loop. The body of this loop will stay the same, but we need an array to define how many times we perform this action. We haven't played with arrays yet, but just think of an array as a bucket with multiple items organized in it. This block says it's going to perform this action once for each item in the bucket. So we simply need to define a bucket that fits 5 things. I'll grab this block that creates an array with blank repeated blank times. It doesn't matter what items are actually in the array, it just cares how many of them there are. So I could create an array with anything in the world, a number, a string, whatever, and I'll repeat it as many times as I want the loop to run. When I update the script, our loop performs as expected. All right, that's just an overview on loops. You can get far more complicated with what loops do, including nesting loops inside of loops, but we're not going to go any deeper in this online course. Take a look at the control worksheet on loops and then move on whenever you're ready.